Hello, welcome to yet another episode where we shall be looking at the revision paper for the grade 11 mathematics end of year examination. So we very well know that in paper 1, there are certain topics that we should expect. And one of the topics is basically the algebra, okay, for paper 1. So algebra normally has a whole lot of, let's say, solving equations, quadratic equations, inequalities, equations that have roots. We have elements of exponents and indices. So all those still dwell within what we call the algebra. Topic number 2 in paper 1 is what we call the number patterns. Okay, in grade 11, remember, we have what we call the arithmetic, and then we have what we call the quadratic at grade 11 level. And then topic number 3 is the functions. Okay, functions and relationships, or functions and graphs. Okay, I'm gonna say graphs here. Now, in this case, we talk about the graphs to do with the parabola, the hyperbola, the exponential, the straight line, and everything that is associated with those graphs. Number 4, we have what we call the financial maths, financial mathematics. Okay, things to do with interest, compound interest, simple interest, and everything that is associated with the finance. And then number 5, we have what we call the probability. Okay, so probability is usually the last question of the paper 1. Now, the mark allocation drastically differs. Okay, if you're to look at how much the algebra counts for, how much the number patterns and functions and so on and so forth. The marks are just distributed amongst all the topics. Okay, so we're going to use this paper just for revision purposes as we prepare for the end of the examination. So it's a paper of 150 marks and the duration is basically 3 hours. So telling us the paper has 10 questions. We answer all of them, number the answers correctly according to the numbering system used in the paper. We need to show all our calculations. Okay, we need to use an approved calculator, and then we need to round all answers to 2 decimals, unless if the question tells us otherwise. Okay, then question number 1. Question number 1, which is always a solve for x. They want us to solve for x. We have 6 sums. The first one is x squared plus x is equal to 12. So step number 1, this is a quadratic equation. We need to create a standard equation. A standard equation whereby everything is on one side. So minus 12 is equal to 0. And then we can do the factoring out. So this is x, and then that is also x. We can say plus 4 minus 3 is equal to 0. And if that is true, meaning that x is a negative 4, or x is just a 3. Okay, so those are the 2 answers for the first part. And then the next part, which is 3x squared minus 2x minus 6 is equal to 0. Now, when I look at this question, chances are high we need the quadratic formula in this case. Okay, I'm just saying chances are high that we might have decimals in this, because normally if the first one is to do with factors, the second question must always be the decimals. Okay, so if I use the quadratic formula, which is the negative b plus minus square root of b squared minus 4ac over 2a. Our a is a 3, our b is a negative 2, our c is a negative 6. When you do the substitution, it's a negative and a negative 2 plus minus square root of a negative 2 squared minus 4 times 8 times negative 6. We are dividing everything by 2 times 3. So my first x value is a negative 1, 1, 2. Oh, x is a 1, 7, 9. So those are the two answers that we have. 1.1.3, where we have the root or the equations with sides. Okay, so I'll jot it aside and say we have x plus 7 minus 1 is equal to x. Okay, so that is our question 1.1.3. So step number 1, we need to isolate the root sign. By isolating the root sign, we're leaving it on one side. So we need to move the 1 to that side. So it's going to be square root of x plus 7 is equal to x plus 1. Then we need to square both sides. Okay, so that we get rid of the root sign. And then that is going to be x plus 7 is equal to, opening this, is x squared plus 2x plus a 1. Let's create a standard equation. 6 squared, when this one goes that side, it will be x. When the 7 goes that side, so negative 6 is equal to 0. Then we can do the factors. Okay, or you can use your quadratic formula, no problem. So I can say this is a plus 3, this is a minus 2. So we know that x will give us a negative 3, or x is going to give us a positive 2. But we do not stop at that, for as long as we have equations that have sets, meaning that we need to test our values. So we need to test our answers. Okay, so I'll start with a negative 3. Okay, testing, you don't need to show the steps of testing. You can do it with a calculator. So you know that a negative 3 plus a 7 is a 4. Square root of 4 is a 2. 2 minus 1 must give us a 1. In this case, our 1 is not the negative 3. When you try with a 2, 2 plus 7 is going to be square root of 9 minus 1. That is a 3 minus 1, which gives us a 2, which corresponds with what we have. So meaning that this is the solution, and then negative 3 is not a solution. Cross it out like that, or you can say not applicable. All right. So that is how that would have been done. Then question 1.1.4, which is the inequality. So we have 2 minus x. Okay, let's say we have 2 minus x is greater than x squared. 2 minus x is greater than x squared. Okay, so let's create a standard equation as well. So I'm going to move this one that side. So negative x squared minus x plus 2 is greater than 0. Okay, you can divide through by the negative if you wish. So that's that's x squared plus x minus 2. The symbol must change to less than 0. Your factors, we're going to have x plus 2, x minus 1. Meaning that the answers we get here, they are known as critical values. We're going to have a negative 2. We're going to have a 1. Now, how do we represent the solutions of this? So since the inequality at this level is less than 0, meaning that we're going to have negative 2 is less x, less with a 1. Alternatively, someone can draw the number line and say this is a negative 2, this is a 1. And then you just connect it like that. Okay. Or someone can still draw a parabola. Okay, so in this case, it's going to be parabola like that. And then it's a negative 2. This is a 1. And then we shade off that bottom part. All right, so that is how that question would have been answered. Then 1.1.5, x to the negative 3/4 is equal to 8. Let's see. It is x to the negative 3/4 is equal to 8. So what we need to do here to eliminate the exponent on the x, we just need to multiply, because we know that this is exponent 1, but we can change it to a base of 2. So that x to the negative 3/4 is equal to 2 to the exponent of 3. Then what I'll do next, I'll multiply this by the reciprocal, which is a negative 4/3 times a negative 4/3. So this will cancel out and we just have a 1. And then this 3 is going to cancel with that 3. I'll be left with 2 to the negative 4. Okay, 2 to the negative 4 is the same as 1/2 to the 4, which becomes 1/16. So x becomes 1/16. All right. And then 1.1.6, we have some exponents, okay, but there's a plus sign in between them, meaning that we need to apply either the K method or we're going to do the factorization. So how is this going to look like? So we have 3 to the x plus 2 plus 3 to the negative x, okay, should give us a 10. So let's write this in a positive format, and we can also split this up. So that's going to be like 3 squared times 3 to the x. So we know that 3 squared is a 9. So that's a 9 times 3 to the x plus that's a 1/3 to the x is equal to a 10. Then I can say that let y be equal to 3 to the x. Then let's do the substitution. It's going to be 9y plus 1/y is equal to 10. Multiply through by y. Okay, I'm going to have 9y squared plus a 1 is equal to 10y. Let's get a standard equation. 10y plus 1 is a 0. Then do the factorizing. Okay. So if this is a 9y, this is a y. This is a 1 and a 1. We can say minus and minus because we have a positive and we have a negative there. So either y is going to be 1/9 or y is a 1. But we say that y is the same as 3 to the x. So 3 to the x, 1/9 is 3 to the negative 2, meaning that x is a negative 2. Or 3 to the x is equal to this 1. And we know that 1 with a base of 3 is going to be 3 to the 0. So meaning that x will be a 0. So that is how we obtain those two answers. I feel the examiners, oh, it's 6 marks. No? Yeah, that's fair. That's fair. I thought it was 3. Okay. Then 1.2. Solve x and y simultaneously if and only if y plus 7 is 2x and then x squared and that is that. So from equation 1, because I've already baptized it for us, let's make y the subject. So y is going to be 2x minus 7. That is equation number 3. Then we need to substitute equation 3 into equation number 2. So where there is y, we're going to replace it with a 2x minus 7. So we have y being 2x minus 7. And then we have x squared plus xy plus y squared is equal to 21. Perfect. So let me substitute that. So I'll have x squared plus x into 2x minus 7 plus 2x minus 7 squared is equal to 21. You need to pay attention and be very, very careful when you're opening these brackets, because one slight mistake is just going to put us off. Okay, so that's going to be x squared. When we open this up, we're going to get 2x squared minus 7x. Opening this square bracket, we're going to have 4x squared. 2 and 7 is 14. 14 times 2 is going to be minus 28x. And then 7 squared gives us a 49. Let me take the 21 that side and equate everything to a 0. So this is a 1x squared plus 2 plus 4 is going to give us 7x squared. Minus 7 minus 28 gives us a minus 35 with x. And then what is 49 minus 21? That gives me, is it a 28? It looks like a 28. Minus 21, which is a 28. That's correct. Is equal to 0. Divide through by 7. This is 5x plus 4 is 0. Factorize this out. We're going to have x minus 4, x minus 1. Meaning that either x is a 4 or x is a 1. But we say that y was 2x. Is it minus 7? Yes, 2x minus 7. Okay, so if it is 2x minus a 7, meaning that y is going to be 2 times 4 is 8. 8 minus 7 is a 1. Or 2 times 1 is 2, minus 7 gives us a minus 5. So that is what we would have done with that simultaneous. Okay, then 1.3. The following equation is given. Okay, these are like vectors being multiplied together so that we get a 0. They want us to solve for x if y is a 3. If y is a 3. So if you replace y with a 3 here, this entire thing is going to be a 0. Okay. So if that whole thing is a 0, what does that mean? So if if y is a 0, meaning that solving this, you'll have x squared is equal to 8, or 5x is equal to negative 2, then you can get the values of x. So in this case, we're saying that we're going to get very many solutions, meaning that x will be an element of real numbers. Okay, so there's a whole lot of answers to expect in that case. And then if y is not a 3, meaning that we have any other number in this place, okay, where x is a set of integers. From our solutions, you cannot find the square root of 8, okay? And then 2 over 5 cannot be 8. So meaning that we do not have a solution for integers. And then where the answer is a rational, okay? So for rational numbers, remember rational number is just a number with a fraction, which is a negative 2 over 5. And then if x is an element of real numbers, meaning that all the solutions, so x is a plus or minus square root of 8, or x is a negative 2 over 5. So that is how we would have obtained that. Okay, so moving forward, question number 2. They want us to simplify this. 25 to the x minus 1 over 5 to the 2x. How do we simplify this? Create the same basis. Né? So 25 is going to be written as 5 squared. That is x minus 1 over 5 to the 2x. Open up the bracket. We're going to have 5 to the 2x minus 2. And then we need to subtract the 2x since we are dividing. So 2x and 2x will be a 0. Our final answer is 5 to the negative 2, which is the same as 1 over 5 squared, which is a 1 over 25. Okay. 2.2. If x is a root 3 plus 2, we must find the value of this. Okay, give the answer with a rational denominator without the use of a calculator. So let me try to write it that side and see. Go to this side. What does the question say? We have root 3 plus 2. Root 3 plus 2, x squared plus 2, then x minus 2. Okay, let's just do that. Let's do the substitution and see how we're gonna move on. So square root of 2 plus 2, this is squared. Now it's a square root of 3. You're adding a 2 over square root of 3 plus 2 minus 2. So let's open the brackets and see. With the top part, we know that root 3 squared is the same as a 3 plus 2 times 2, and that is going to give us 4 square root of 3. 2 squared is a 4. Now we are adding a 2 outside over. This 2 is going to cancel that 2, so you're only left with square root of 3. Simplify this, that's 3 plus 4 is 7, plus that gives us a 9. 9 plus 4 root 3 over square root of 3. What does the question want? The question wants us to give, does the denominator need to be rationalized? Is that what they want? Okay, rational denominator, which means it's a fraction. This is irrational. So what we're going to do, multiply by root 3, and then multiply by root 3. So 9 times root 3 is going to give us 9 root 3 plus 4 root 3 times root 3 is going to give us a 12, because root 3 times root 3 gives us a 3, then times 4 is a 12, over, that is a 3. You can divide this through, so that 9 root 3 over 3 plus 12 over 3, which is 3 root 3 plus a 4. So that becomes the final answer of interest. Okay. Having looked at that, we need to move on, and then 2.3, if square root of 10 is given as that, they want us to calculate the value of the 5th root of 316,2 without using any form of a calculator. So what we know is that the square root is 3,162. What does the question want? The 5th root of 316,2. Something like that. So what we're going to do is, let's see. When you talk of 5th root of 316,2, is the same as someone. Okay, so I'm comparing it this and that. So this number was multiplied by 100 for them to get the 316,2. So it's going to be the same as the 5th root of 3,162 times 10 squared to the exponent of 1 over 5. Okay, something like that. Then we were told that 3,162 represents a root of what? Root of 10. So I'll replace that to a root of 10 multiplied, okay, by 10 squared. And we know that square root of 10 is the same as 10 to the exponent over half. Okay, this is 1 over 5. And then if it is 10 to the exponent of half, and then this is 10 squared, we need to plus this together since the bases are the same. So that's going to be 10. What's a half plus 2? That's going to be 5 over 2. So 5 over 2. Now multiplying it with a 1 over 5. So this cancels that. And then our final answer needs to be just a root 10, which is also the same as 3,162. Okay, so that is what we are. getting for that case. All right, then question number 3, which is the number pattern. The following linear pattern is given. We have 8, 6, 4. They told us it's linear, so the common difference is the same. You're subtracting a 2. So they're asking us which term will be the first to be negative. So if you subtract 2, you're going to get a 2. Subtract 2, you're going to get a 0. Subtract 2, I get a negative 2. So if this is 1, 2, 3, 4, 5, 6. So you tell us the 6th term. Okay. Then determine the Tn. So with the Tn, get the constant, which is a negative 2 with the n. And then we get 8 minus 2, which is a plus 10. That gives us the general term. And then they want us to get n if Tn is negative 2008. Okay, so what we're going to do is that if n is negative 2008, we said our Tn is negative 2n plus 10. We're equating this to negative 2008. Move this 10 to that side. Negative 2n is going to be equivalent to negative 2018. Divide both sides by negative 2, meaning that the n is a positive 1009, something like that. Okay. And now we move on. 3.4. This linear pattern forms the row of the first difference of the quadratic. Okay. T4 of the quadratic is 58. Determine the first 3 terms. Okay, so let's interpret this question this way. So we know that with a quadratic pattern, we have 2 differences. Ne? This is T1, T2. This is a T3, and then T4. Am I doing the right thing? Let me just erase it out and put it nicely. So this 8 is going to be between T1 and T2. The 6 is T2 and T3. The 4 is between T4 and T3. But they're telling us that the T4 is 58. The number here is 58. What do they want? They want the first 3 terms. So we need to move backwards. Okay. Meaning that from a 58, we need to, are we adding a 4? Or we are subtracting a 4? We are subtracting a 4. So that this is a 54. And then we subtract a 6, which is a 40 man. It's going to be a 48. And then 48 minus that, we're going to end up with a 40. So if you have to show the steps, you just have to do the subtraction and tell us that T3 is going to be a 58 minus a 4, which is a 54. T2 is going to be a 54 minus 6, 48. And then T1 is going to be a 48 minus 8, which comes a 40. All right, then question number 4. We have a quadratic pattern or a sequence, 75, 53, 35. Write down the 5th term. So what are they doing here? From 75 to 53. This is a 2. That's a 2. So they are subtracting 22. Okay, that is for the first part. And then this, they're subtracting 18. And then after they're subtracting a 14. And then after, they should subtract a 10, meaning that 21 minus 10 gives us 11. 1, 2, 3, 4, 5. So T5 is going to be number 11. Determine the nth term. So with the nth term, we need the second difference. This is going to be a plus 4, a plus 4, a plus 4. So this should be equated to the 2a, meaning that our 2a is a 4, a becomes a 2. And then 3a plus b must be equated to the first difference, which is a negative 22. If a is a 2, we shall have a 6 plus b is negative 22. B becomes negative 28. A plus b plus c should be our first term, which is 75. So 2 minus 28 plus c should be a 75. This should be negative 26, so it's a 75 plus a 26, 101, okay? So meaning that our Tn is going to be 2n squared minus 28n plus 101. Then which term in the sequence C has a value of 131? Which term in the sequence has a value of 131? Now, if you look at it nicely, okay, does this make sense? Because they're telling us that the first term is a 75. Let me just check nicely. The first term is a 75. But then we're looking for a value of 131. Does that mean this pattern is gonna increase afterwards? That is correct, because it is a parabola. Okay, so I'm gonna equate this to 131, move it that side, and I'm gonna end up with a 30. So 2n squared minus 28n plus 30 is 0. Divide through by 2n squared minus 14n plus 15 is a 0. And then factor this out, n minus 15, n minus 1. Does that make sense? There needs to be a positive somewhere, but this is a negative. What did we do wrong? Did we do anything wrong? No, this is a negative. It is a negative here. Okay, so that is a negative and that's a negative, meaning that we need to have a plus here, meaning that n is a 15, or n cannot be a negative number, okay? So which term? So term number 15. Then determine the maximum of the following pattern. How many marks? It's 4 marks. Whenever you look for maximum, you need to use the quadratic approach or even a minimum, okay? Whereby if we look for x is negative b over 2a. So we need to find our a, we need to find our b. And what is the pattern? Negative 15. And then we have negative 53 over 5. And then we have negative 7. I think that's enough. Let's subtract there. When we subtract that, what do we end up with? Or before we even subtract, does this pattern relate to any of the things that we saw above? Because this is a 75, this is a 53, this is a 7, and then a 21. So which means that dividing by negative 5. They're getting the entire pattern and then they divide it by what? They divide it by 5 negative. Meaning that if we are looking for our answer, we can start by looking for the maximum of this pattern. And then the answer we get, we divide it by 5. Okay, so that is going to be, remember, our B was a negative 28. Our A is a 2. So negative with a negative 28, 2 by 2. What does this give us? A 28 over 4, which is a 7. That is a 7. Then, if 7 is our is it minimum? Because it is a positive 2, which means it's the minimum. That is the minimum. And I guess that's what the question is looking out for. Now the question wants the maximum value. So how do we get the maximum value? How do we get the maximum value? So we can get the general term, okay? And then replace that number of hours. Remember the general term was 2n squared minus 28n plus 101 plus 101. Then let's do the substitution. So it's a 2 times a 7 squared minus 28 times a 7 plus the 101. What does that give us? Let me punch this into my calculator. So this gives me a 3 as my answer. But now, since we said we are dividing by -5, it simply means that the maximum that we are interested in is going to be a -3/5. So the y value. So that is what the question technically wanted. Okay, question number 5, which is the financial maths. Computers are purchased for 300,000, depreciates as shown the diagram below. Determine the rate at which the depreciation took place. Now the question is not specific whether it is straight line depreciation or reducing balance. But I will assume that given the nature of the graph, okay, it is a straight line. So it's going to be a straight line depreciation. So A should be P into 1 minus IN. So the final value is 135,000. Initially, it was 300,000 into 1 minus IN, which is going to be 5I. So when you divide both sides by 300,000, okay, what is that going to give us? It's going to give us a 9/20. Okay, but negative. Is it positive or negative? No, it's a positive for that case. Then when you subtract with a 1, then it becomes a negative. Which negative? Okay, if I divide by 5, negative, which means the I becomes 11%. All right, so with 5.2, they're telling us that Peter is a farmer and he made a profit of 3.5 million. He decides to buy a new tractor for this much, and then he invests the rest of the money. With this investment, the tractor has to be replaced within 6 years. So the question is, how much, okay, how much does Peter have available to invest? Okay, so that's going to be 3.5 million, which can be written as 500,000 minus 250,000. Okay, so that's going to be a 250,000. So 1.25 millions will be readily available just for investment. And then if the average inflation rate is 4% per year over the next 6 years, what is the estimated cost of the new tractor. So if the new tractor is costing 2,250,000, whenever there is inflation, we normally apply the compound interest, okay? So that's going to be A is equal to P1 minus I, no, it's plus I to the exponent of N, which is a 2250,000, 1 plus the I, which is 4%, 4 over 100 to the exponent of 6. Okay. So when we punch this into our calculator, what does it give us? So 2,250,000, 1 plus 4% to the exponent of 6. So I'm getting 2,846,967,79. So that is how much now the new tractor is going to cost within the 6 years. All right, then 5.2.3, the old tractor depreciates on a reducing balance rate of 14%. What is the value of the old tractor? So we're going to use the A is equal to P1 minus I to the exponent of N. So still the same value, 2,250,000, 1 minus 14% of 14 over 100 to the exponent of 6. Okay, so when I punch this into my calculator, what do we get with the depreciation? I'm getting 910. Okay, 910, 276,28. Okay, that's how much we shall have at the end of the 6 years. And then 5.2.4, Paul invests the amount calculated in 5.2.1 for 6 years. But for the first 4 years, the interest is 9% per annum compounded monthly, and thereafter it reduces to 8.5 compounded quarterly. Okay, so if I have, let's say, a timeline, they said for the first 4 years, okay, the interest rate is 9%, but we are compounding it what? Monthly. Okay, and then we have 8.5, which is quarterly. Okay, then they're telling us that 1 year before the end of the 6-year period, Peter has to withdraw 100,000 for the unexpected expenses. Okay, so meaning that at this point, at 5, there is a withdrawal of 100,000. Okay, assume that the old tractor will be traded in at its reduced value after 6 years to partially finance the new tractor. Determine with necessary calculation if Peter will have enough money for the investment or from his investment to replace the tractor. So remember, initially the starting amount is 1,250,000. Okay, so we can go step by step and then see how much is going to be in the account, let's say after 5 years, and then we do the subtraction. Alternatively, we can do the 1,250,000 for the entire 6-year period, okay, bearing in mind the interest changes, and then now we subtract this with the 1-year growth of the 100,000. Okay, so this is what's going to happen. This is what's going to happen. I'm going to get the, do I have space there? No. So I'll say 1,250,000 into 1 plus. Okay. So the first rate was a 9% compounded monthly. So it's a 0.09 over 12. Now it's going to go for the first 4 years. Okay. This is 4 times 12. Then whatever is left, okay, must grow for the next remaining 2 years, but being compounded quarterly. So 0,085, okay, over 4 to the exponent of 4 times 2, which must give us 8. So let's see, before the withdrawal is made, how much is it gonna be? Or we can even just look at it as a whole and say minus, this is gonna be 100,000 into 1 plus the 0,08 over 4 to the exponent of 4 times 1, since it's just 1 year. Okay, so that we can just punch everything in the calculator at the word go. Alternatively, people can choose to do it step by step. Okay, so 9% over 12. We're saying to the exponent of 12 times 4 is 48 into 1 plus. This is going to be 8.5% over 4. Okay, to the exponent of 4, and that is 8. Now we are subtracting 100,000. Okay, 1 plus 8.5% over 4 to the exponent of just 1. Yeah. Okay, so what I'm getting is 2008, 265.87. So this is what's gonna be within the account after that period of time. Okay, but then they told us there's something that is being traded in. Okay, but what we know is that initially the tractor is costing 28 something. Okay, this is the amount that the new tractor is gonna cost. Okay, but then if we also subtract this 9 so that we find the new cost of the tractor. So what's gonna happen is that I need to subtract this 910 from what I have, so that we see how much is needed. Okay, let's go there and see. So 910, so this is this much. We are subtracting 910, okay, 276.28. So let's see. So 2008, 265.87, subtract 910, 276.28, meaning that we only need 1097989.59. So you can see. Okay. Alternatively, maybe just not to confuse people, let's get the amount that was saved. Which amount was, we said it was a 28,46967.79. Let us subtract the 910 to 76.28. What does this give us? So that we can see the exact cost or the exact amount that the tractor is gonna cost. So 1936691.51. So this is the new cost of the tractor. Okay, but this is how much is gonna be in the account. What is the question asking for? The question is asking to determine with necessary calculation if Peter will have enough money. So therefore, he will have enough money. All right, so that is how we're meant to go about the finance question. Then question number 6, which is the functions. We have the two graphs. F of x is a straight line, G of x is a parabola. Okay, the intersectors B and Q, A and B are intercepts. We have a turning point and They want us to get the length of AB. So they are indirectly asking you to determine the coordinates of the intercepts. So the graphs, or the graph that is passing through A and B is the parabola. So we're gonna equate the y to 0. Divide through by negative, it's going to be x squared plus 4x minus 12 is a 0. When we factor this out, I'm seeing x with a 6, x with a minus 2, meaning that x is a negative 6 or x is just a 2. So if this is a negative 6 and this is a 2, how many units do we have? Those are basically 8 units. Then they want the length of FE. So from this point to that point, what is the y-intercept of F? It's a 2. Okay, we can get it from here. And then the y-intercept of G is a 12, okay, when x is 0. So meaning we're going to have 12 minus 2, which gives us 10 units. And then they want the coordinates of the turning point D. So for us to get the coordinates, we can just get the midpoint here, or we can use the x is negative b over 2a, either way. So if I use the midpoint, that's going to be a negative 4 over 2, which is a negative 2. So the x here is a negative 2. Then I need to substitute this into the G graph. That's going to be negative with a negative 2 squared minus 4 into negative 2 plus 12. This is going to be a negative 4 plus 8 plus 12, which is a 20 minus that, which is a 16. So negative 2 and 16 will become the answer there. Okay, then we move on. They are telling us to find the range of G. So y should be less than or equal to 16. That's how we write the range. Okay. So somebody can say negative infinity is less y is less 16. Then determine the average gradient of G, the gradient G between point D and B. Between point D and B. So average gradient is just the same as the normal gradient formula, okay, the change in y over the change in x. So it will be a 16 minus 0 over negative 2 minus 2. So 16 over negative 4, which becomes just a negative 4. So the average gradient is a negative 4. All right. 6.6, they want us to get the coordinates of Q. Okay, so when you look at Q, it's the point of intersection for the two graphs. Okay, so we need to equate both equations. So negative x plus 2, okay, I'll say f of x should be equal to g of x. So negative x plus 2 should be equivalent to negative x squared minus, what are we subtracting? Okay, so it's minus 4x plus 12. So let's move everything to the left. So it's going to be x squared plus 4x minus x plus 2 minus 12 is 0. X squared plus 3x minus 10 is a 0. Factor that out for quadratic formula. Okay, so if I make this a plus and that a minus, I think I'll be able to get that expression. X is a negative 5 or x is a 2. So the 2 was the point of intersection. So our point of interest is this, meaning that the coordinates of Q are going to be negative 5. And then if we get a negative and a negative 5 plus 2, that gives us a 7. So those will be the coordinates of Q. Okay, so having seen that, then we go to 6.7, for which values of x is f of x greater than the g of x. So since that's a 2, and then this is a negative 5, where does the f be above? So f is the straight line. Eh? So it's above in this region, and it's also above in this region. So it's on top of the graph of G. So we're going to say when x is less than -5, or when x is greater than a 2. And then 6.8, for which value of k? Now they're talking of a value, not values. Okay, for which value of k shall we have -x squared minus 4x plus k equal to 0 have 2 equal roots? So for a graph to have 2 equal roots, it simply means that the turning point is just on one value, okay, or something like that. So in this case, this x here, sorry, this k is more like a shift. In other words, how many units must we move the graph? So since this is a 16, okay, meaning that we need to move the graph 16 units downwards, but initially the k that was here was a 12, okay. So we're going to say that 12 minus 16, which gives us a -4. So what does that mean? The graph needs to move those number of units downwards. All right, then 6.9. Use the graph to solve the inequality. F of x times g of x should be less than or equal to 0, meaning that the two graphs multiplied must give us a negative. This happens if one graph is above, the other graph is below, or this graph is below, and then this one is above. So for f to be above the x-axis, we have a scenario like that, where f is above and g is below. I think it's only happening somewhere here, okay, where this one is below, and then the other one is above. Other than that, the rest doesn't make sense. So we have -6. So when x is less than -6, that's when everything happens. So x is less or equal to -6. And then for the 0 part, we know that x must be just a 2, the point of intersection. All right, then question number 7. We're given f of x, which is an exponential. This is a hyperbola by nature of the equation. P is a point that is having 1 and 1/3. Q is -2 and 9, lies on F as well as the vertical asymptote. They want us to get the value of A. So since A is on the exponential, so we need to look at the graph of F and indicate or identify what our point is. So we have this point which is -2 and the 9. So where there is y, I'll put a 9, and then that will be a to the -2. Okay. So what's going to happen here? We know that this is the same as 1/a² equals to 9. You can do the cross multiplication, which is 1/9, and then find the square root. So a is going to be a plus or minus 1/3. But looking at the shape, okay, looking at the shape of the graph, remember a is going to be just the 1/3 because of the shape. It's not a reflection on that side, so it cannot be that. So a becomes just 1/3. And then they want us to get the equation of g, which is the hyperbola. So we have the asymptotes. Okay, it's going to be k/x. The vertical is -2, which means it's going to change to a +2. And then the horizontal is just 1. Let's get any other point where the graph passes. It's this point of 1/3. Okay, so we shall say 1/3 is equal to k over, it's going to be a 1 plus 2 plus 1. So k/3, when we move this one this side, it's going to give us a -2/3, multiply both sides by 3, meaning that k is a -2. So if k is a -2, the question wanted the equation, meaning that g of x is -2, x plus 2 plus 1. They want the domain of g, x is an element of real numbers, x should never be a -2. Write down the equation of k of x if k is the function obtained after reflecting f about the y-axis. So if you reflect exponential about the y-axis, the sign of the x must just switch positions, okay? So meaning that instead of it having 1/3 to the x, it's going to be 1/3 to the -x. And then we are moving it 2 units down, so -2. This becomes the equation of k of x. Okay, so that is that. And they want us to give the range. So range, those are basically y values. And since we know that -2 is an asymptote, we're going to say that y must be greater than -2. So 4, the equation of the axis of symmetry for G in this form where M is negative. So how do we get that? We normally say y is equal to -x plus c. Okay, this is the formula that we normally use. For us to get the c, use the point of intersection, which is -2 and 1. So it's 1 is equal to negative and -2 plus c. And then c is going to be 1 minus 2, which is a -1. So the equation becomes -x minus 1. And then 7.5. 7.5 for x is greater or equal to -2. Okay, determine the values of x where f is greater. So f is above, where f is above the g. So we see between -2 up to this point of 1, this graph will be above. So I'm going to say -2 is less or equal to x is less. No, it cannot be equal. Why? Because the -2 is an asymptote, but it can be equal to 1. And then use the graph to solve the inequalities. So when you're looking at this graph, we need to manipulate it around and say x plus 2 is greater or equal to 2. Does that make sense? It doesn't. Let's move this one to this side. It's going to be -2 over x plus 2 plus 1 is greater or equal to 0. What was the original equation? Original equation was negative this. Okay, that's the original. So meaning that if we are talking of the g of x being greater or equal to 0, where do we find this graph to be above the x-axis? Okay, so the graph is above the x-axis when x is less than -2, because on this section, the graph is above. Even at this point, when it goes above, when x is greater than 0. So we're going to say that x needs to be greater or equal to 0, x needs to be less than -2. So those are the two solutions that would work for that particular question. Question number 8. Question 8. A golf ball is hit from point A to point B, and then the path of the golf ball is placed in the Cartesian plane so that A is on the y-axis, B is on the x. Point A is 30 meters above the ground, point B is 300. Okay, the path is modeled using this parabola. Ball passes through 230. Okay, determine the maximum height that is reached by the ball. Now, what we need to know is basically the points, okay? Since the ball passes through the point 230, so at this point here, okay, this is gonna be a 30, and then that's gonna be a 200. If that is true, meaning that our x-intercepts, so if this is, then this is a 300 there. So what do we do? What do we do when we have a scenario like that? Simply means that the 100 is somewhere there. Okay. Determine the maximum height that the ball reaches above the ground for 5 marks. They want that distance there from the ground. Okay. So what we're going to do in this case, we can do the modeling. And if this is our y-axis, simply means that the y-intercept is a 30. So if I have y is equal to ax squared plus bx, this c becomes a 30. Then I can do the substitution of 200 together with the 30, and also use the 300 and then 0. Okay, so if I use the 300 and 0, it's going to be 0 is equal to a into 300 squared plus b into 300 plus a 30. 300 squared, that's going to be, is it 90,000? Is it something of the sort? It should, okay, because 3 times 3 is 9. And then so it's 90,000 A plus 300 B plus 30. This is equation 1. If I use 230, this is equal to 0. No? Then if I use 30 is equal to A into 200 squared plus B into 200 plus a 30. So 30 becomes a 40,000 A plus a 200B, okay, plus a 30. This is 0, sorry. Okay. Then from there, I have this equation and that equation number 2. I need to solve them simultaneously. Okay, so I have a 30 plus 300B plus 90,000. This is a 30 plus a 200B plus a 40,000 equals to 0 equals to 0. Okay, so I can multiply this top part by 2, multiply this bottom part by 3, and then I'll subtract. Okay, so what will the top part become? It's going to be a 60 plus 600B plus, that's 18 with those zeros. And then this is going to be a 90 plus 600B plus a 12 with those 4 zeros. We said we are subtracting that. So this is going to cancel that. This is going to be a negative 30. 18 minus 12, that gives us a 60,000. But this is A. This is a plus, is equal to 0. Then let's move the 30 that side, meaning that A is going to be a 30 over the 60,000. This cancels that. By 3 is a 1. By 3 is a 2. So A becomes 1 over 2,000. And then how about B? We can just do the substitution back. Okay. Alternatively, because we need A, we need B. Okay. Before we can get the maximum. So 1 over 2,000, we put it back. We look for B. So 30 plus 300B plus, why don't I use 200? It's going to be easy. This is 40,000 over 2,000. 3 zeros go, this and this gives us a 20. 20 and that is 50. Okay, so 200B is equal to negative 50 over 200 over 200. So B becomes negative 1 over 4. Okay. So for us to get the maximum height, we can say x is negative b over 2a. We want to find this value here. So our b is negative a quarter, so negative and negative a quarter, twice times 1 over, we said 2000. Okay, so that's gonna be a quarter. This is gonna be 1,000, so a quarter of 1,000. What does it give us? It's a 250. So we're getting something like a 250, and then we do the substitution. Okay, so alternatively, if that is too long, we could look at a half of this 200, and then it becomes 100 here. And then if x is 100, and then we just do the substitution back into the equation, and then we come up with our answer straight away. Okay, so that is how we would have answered that. Then question number 9, given that A and B are two different events, probability of A is this, probability of B is that, A or B is that. Are the events mutually exclusive? We need to motivate our answer. So we know that for mutually exclusive events, the intersection needs to be a 0. Okay, but is our intersection a 0 in this case? That's one question that we need to ask ourselves. Is the intersection a 0? And the answer is we don't know. Let's see. So probability of A or B is the same as probability of A, which is 0.5, plus the probability of B minus the probability of A and B. So that's a 0.3 minus, we need this A and B. So if this is 0.7 is equal to 0.8 is equal to negative of the intersection. Move this one that side, you get a negative, meaning that the intersection is 0.1. So the answer is no, because the intersection is not 0. They want us to draw a Venn diagram to substantiate what we have. Okay, so if I put my Venn diagram this side, remember we're dealing with decimals. So our sample space is a 1. That is A, that is B. We found a 0.1. A was a 0.5, which means we have a 0.4 there. B was a 0.3, meaning that we have a 0.2 there. So A or B was a 0.7. So there has to be a 0.3 outside there, so that the entire set adds up to 1. Then calculate the probability of not A or B. Okay, so we're saying the probability of not A or B is going to be the probability of not A plus the probability of B minus the probability of not A and B. Okay, that's one thing that we need to look at, meaning that we have a 0.5. Okay, because A is 0.5, then not A will be 0.5. B was given as a 0.3 minus not A, okay, outside of A, which is here, and B. So it's a 0.2. So 0.8 minus 0.2, the answer we get is a 0.6. Then are events A and B independent? Motivate with calculations. So we know that events can only be independent if the probability of A and B is the same as the probability of A times the probability of B. So 0.5 multiplied by 0.3. What does it give us? It gives us a 0.15. This is not the same as the 0,1 that we got. Therefore, events are not independent. All right, then question 10. Parking area has 14 VWs and 18 BMW cars parked. We have no other cars during the afternoon. 2 cars were stolen, one early afternoon and the other later. They want us to represent this in a tree diagram. So we can say that the first car to be stolen can be a VW or a BMW. The second can be a VW or a BMW. VW or a BMW. Let's indicate the probabilities. So we know that 14 and 18 gives us a 32. So 14 over 32, this is 18 over 32. If the first one taken was a VW, then we're going to be left with 13 VWs over 31. This is going to be 18 over 31. Okay, so this is a 14 over 31, and then if it was a BMW, it's going to be 17 over 31. What else do they need? They want you to indicate the probabilities on the branches, also the outcomes. So VW, VW, V and the B, B and the V, and then B and the B. Then determine, using the tree diagram, the probability that both cars stolen will be BMW, so BB. It's gonna be 18 over 32 times 17 over 31. What do we end up with? So I'm getting 0.31 if I'm to round off 2 decimals. And then at least 1 VW will be stolen. So the word at least simply means the minimum. We should have 1 VW. So we have this, we have that, and then we also have that. So what we can do, since we have 3 options, we can just say 1 minus the probability of 2 BMWs. 1 minus 0.31, then it will be 0.69. So that is how we would have obtained that. Alternatively, multiply these 2 probabilities, you add, and then you add to that. You still end up with a 0.69. All right, so that brings us to the end of this paper 1. I wish you guys all the best in your preparations. And I believe you guys will make it, okay? So we shall stop there. Let's meet when we are discussing paper 2. Bye-bye.